everyone. Good day and welcome to our September public global R&D meeting. It's a pleasure to have you all, and we have some exciting updates and demo for you today. As always, we have some updates on metrics, the roadmap, and on threshold ECDSA. And then we have some news about the search engine optimization or support actually, and inter-canister query calls. And then our demos today are about DFX improvements, a quick hack on Uniswap, and our highlight will be from Dennis from Apocalypse. We'll start with some metrics today featuring Kyle, who has looked some neurons. So Kyle, what have you found?
Thanks, Jan. Hello, I'm Kyle Langham, the Director of Data and Analytics here at DFINITY. And let's talk about some trends on the NNS. As a follow-up, there's a great blog entry on DFINITY's Medium page if you want more information. So let's talk at when Genesis occurred, the NNS was pre-configured with some neurons for contributors to the Internet computer prior to the launch. Those were seed round investors, DFINITY, early contributors, airdrop participants, etc. We passed a milestone at some point, and I don't think it really caught anyone's attention, where the majority of the ICP on the NNS is actually post-Genesis. So as we stand today, 57% of the ICP on the NNS is from post-Genesis participants, and that accounts for 61% of the total voting power on the NNS today. If we go to the next slide, I'll go into why I think that 61% is actually increasing pretty drastically or pretty quickly. First, special thanks to ICP Jesse for helping me make these charts in 3D to make them pop. And what you're looking at here is the ICP on NNS as it stands today, bucketed by dissolve delay. So the minimum amount of time before it could possibly dissolve the neuron, and then colored by whether that neuron is dissolving or whether or not it's in the locked state. So you can see purple is dissolving, and essentially the vast majority of ICP that's dissolving on the NNS is dissolving in the next 2 years. A big portion of that is those pre-Genesis neurons that the Genesis launched, or that the NNS launched with at Genesis. However, what we see is a significant trend towards new participants to the NNS staking for longer dissolve delays and keeping their neuron locked. And so look at that all the way on the right there, that 8-year neuron gain we have 120 million ICP and 8-year neurons. So I want to say that again for effect. There's 120 million ICP locked in 8-year neurons as we are today. That's almost a quarter of the total supply of ICP. And for reference, on December 1st of last year, we had 53 million. So that number's been increasing pretty quickly over the last 9-10 months. If we go to the next slide, I'll show you the effects of that. So here's a pie chart showing voting power on the NNS today based on the dissolve delay. And this is for known neurons only. So these are neurons that the neuron ID has been searched for on the public dashboard. And you see quickly the amount of voting power held by longer term dissolve delay neurons is significant. It's the majority. And so there's certainly a trend on the NNS towards voting power being held in participants who have a longer term commitment to the Internet computer. On the right there, you see just a quick data point in terms of decentralization. So 39% of the voting power on the NNS today is held in neurons with less than 50,000 ICP in them. Take that for what you want. We also don't have an idea of whether or not a person or an entity owns multiple neurons, but I wanted to include it there just for decentralization purposes. If we go to the next slide, you see I took a chart specifically from Stepanka, if you mind going to the next slide. I have a chart in here one back, there we go. Specifically from the public dashboard. I wanted to include a chart from the dashboard because I just want to call out the great work that the dashboard team has done. We have a treasure trove of data and information on our public dashboard. And this is one great example of it. This is voting participation on governance topics. And what you see so far is back in February, there was a drastic increase in voting participation on the NNS. And that is primarily due to the changes in the governance weighting and the governance proposals on the NNS. I think it's probably appropriate to give special recognition to the community member Wenzel Bartlett, whose leadership was pretty instrumental in that. And then post-February, you do see a slight increase over time, very slow, but a noticeable slight increase in that voting participation, such that we've gone from 40% participation to close to 50% now. That is due, again, where there's this trend of non-voters tend to be dissolving their neurons, whereas new participants to the NNS tend to be staking for long periods of time, keeping their ICP locked, keeping their neuron locked, and also participating in governance. So it's a nice healthy trend. So let's sum it up. Let's go to the next slide. And here's the main trends that we're seeing, right? So voting power, again, is moving towards the hands of post-Genesis stakers. That's a trend that we continue to expect to continue. New participants tend to be staking their ICP for longer dissolve delays, tend to be keeping it in the lock state. And then the results of that obviously is voting power on the NNS is moving towards that longer term commitment, those participants with that longer term commitment. And then again, we're seeing some slight improvements in the governance voting participation. If you have any questions, put them in the chat, and I'm going to hand it over to Pete next.
Thanks, Kyle. Happy to see that our neurons are healthy, doing well, and moving in the right direction. Next up, as you see the slide already, we have our classic, the roadmap update. This time presented by Pete, our head of product. Take it away, Pete.
Hi there. Thank you, Gian, for the introduction. I'm Pete Lidwell, head of product. So as a quick recap, we decided a few months ago that we would move away from managing large bundled IC versions named after metals and the like, but instead would provide smaller, more individual roadmaps for the different IC work streams. And the goal here was to provide more visibility and to release earlier and more often when things are ready. So there's an awful lot of detail on the slide. So quickly, this isn't the only place you can see our roadmap. We'll publish an update on the forum. And also you can find details around many of the work items on here on the Internet Computer site. There's a QR code at the top left here that you can scan, and that will take you directly there. So I'll now walk you through some of the highlights of what's on this roadmap and what's changed since the last global R&D. So next slide. High level work continues on the Bitcoin integration. Our launch date is still planned for November for mainnet. There's a more detailed update later in the presentation. You may have seen on Twitter that HTTP outcalls is now launched in beta. This is super exciting as it unlocks, it's really a blockchain first and unlocks a whole new world of smart contract types and dApps. So super, super exciting there. Deterministic time slicing deterministic time slicing has been rolled out. Whilst this is mostly an invisible change, it's actually an important precursor to fixing problems like large canister updates. So also super important. And then lastly, inter-canister query calls is a high priority on this roadmap, and more details will be later in the presentation. Next slide. So work continues on a more mainstream custom domain solution, though the beta version is out there today. Very excitingly, we launched SEO support. I really don't want to say much more about it because, again, the team is giving an update later in the presentation, but super exciting. We're working on also certified headers. Whilst that may not mean much to many people, this actually unlocks features like caching support in the future. Next slide. As many of you might have seen, we launched a new UI for internet identity with a lot of community involvement in that process. The NNS team continues to work on building out support for the SNS. SNS remains a high priority. The token standard working group continues to meet. They're now working on an ICRC2 extension to ICRC1. Which is a community requested, which will support community requested payment flow extensions. We're also working on a ledger indexing solution for the SNS tokens, which will make building wallets around SNS tokens significantly easier. And then lastly, we're working on the zkBTC ledger and Minter, and that remains a high priority so that we can launch this around about the time that Bitcoin integration goes live on mainnet. Next slide. The user-facing community funds were actually shipped in the NNS a couple of months ago, but we didn't really talk about it last time. This actually introduced a significant amount of flexibility in how you could opt in and out of the community fund. And we've actually seen recently the community fund grow by about 3 times. So we're glad to see that has some impact. The SNS work continues. Our first SNS, which we're calling SNS1, is going to come imminently. We'll keep you up to date through all of the usual communication channels on that. And lastly, we're continuing to work on maturity handling improvements, which are consistent with the January, February, March proposal. So those are still in flight. Next slide. Moving on to the developer experience, we shipped what we're calling DFX shared replica. I won't go into too many details because the team is giving an update later in the presentation. We also launched a beta version of DFX Quick Start. This aims to get developers up and running, deploying to mainnet much more quickly. We shipped a beta version of bringing up a local SNS, which is super important. It allows the whole ecosystem to try out an SNS locally, try out the configurations, run through the flow. A more polished version of that's coming soon, so that's why that's labeled as in beta. There's lots more stuff in the pipeline for the developer experience. So I just wanted to highlight that the majority of that work coming is all trying to address high priority issues raised by the community. Next slide. Lastly, moving on to the ops and infrastructure side of the world, the replica hardware 2.0 spec was published. We ran some tests with the initial vendor, but we're actually also investigating some additional vendors. The build and cargo tests are now ported to Basel. We've also got a more streamlined process now for onboarding node providers, called the basic node provider onboarding. And then lastly, we're investigating solutions right now for a more generic and public IC monitoring solution. So with that said, I think for the highlights from the roadmap, thank you very much.
Thank you, Pete. As you might have noticed, what Pete just talked about is really what the R&D team is currently working on. It does not include a lot of other stuff that we have on our roadmap that we are thinking about. And because at this time, more like a teaser, we want to also put those things out, maybe on the webpage, maybe in the next meetings here, just to give you a heads up on some of the topics that are also you're thinking about, and to avoid maybe surprises that these things are also somewhere on our pipeline. Or if you're interested in helping us on some of those things, then also we can talk, because we have a ton of ideas on these things as well. Right, let's move on to our next speaker, which will be Raymond, who talks about boundary nodes, one of the areas that Pete just briefly mentioned. But the boundary nodes are a very important part of the internet computer. Right now, they're not as much part of the internet computer as we want to be. And yeah, please tell us more.
Hi, everybody. So my name is Raymond, and I'm the manager for the boundary node team. The boundary nodes are the gateway to the IC, and when you access a DApp, your traffic is basically flowing through them, but they're not as centralized as we would like them to be. So I'm going to take a few minutes and talk to you about the current architecture, and I'll recap some of the work that the team has done over the past few months, and some features that we're currently working on, and then I'll talk about the future architecture that we're planning. Next slide, please. So what are the boundary nodes? So they're the gateway to the IC, like I said. When a user request lands on the boundary nodes, the boundary node will route it to the right canister and to the right replica. And other than routing requests, the boundary nodes will also do many things like terminate TLS. They'll load balance traffic across the replicas. They also provide some caching and rate limiting capabilities to protect the IC. Next slide. So this is what today's architecture looks like. the traffic flows from the clients through the boundary nodes to the replicas. The boundary nodes are globally distributed, but contrary to the replicas, they're not managed by the NNS. And at the moment, they're all DFINITY owned and operated. So obviously, this is not as decentralized as we would like it to be. Next slide. So over the past few weeks, we've released some new features. So SEO has been already talked about, and Or will talk about it right after this. We've also made a significant effort moving the boundary nodes to the same platform as the replica nodes. So we're now building the boundary node images the same way that we build the replica node images. And this allows us to take advantage of the same tooling and the same best practices. And it will also allow us to move towards community managed boundary nodes and more decentralization. We also have some new features in the works. So asset caching is going to allow us to improve the user experience by providing faster load times and supporting custom domains so that developers can easily expose their dApps on a domain of their choice instead of having to spin up their own custom infrastructure so that to do it. Next slide. Yeah. So longer term, we're trying to improve the decentralization of the boundary nodes, and we're building a new architecture with these goals in mind. So no single point of trust. Users should be able to interact with the IC without having to trust a single entity, in this case, DFINITY, since all the boundary nodes are owned and managed by DFINITY. Usability, where users should be able to conveniently access the IC using a stock browser, not like special software. And censorship resistance and legal compliance. So we want individual node owners to be able to independently comply with their local legal frameworks. So for example, if you need to block gambling in a particular geography without having to block everybody else who's running a boundary node. And open, but basically anybody can run a boundary node. And as much of the functionality of the boundary nodes is managed by the IC community through the NNS. Next slide. Thanks. So this is what the new architecture is going to look like. We want to split the functionality of the boundary nodes into two parts. So there's the HTTP gateway and the API boundary nodes. The HTTP gateways are going to provide an endpoint for the users to terminate TLS, and they will serve the service worker, which is what our boundary nodes do today. And they'll be self-managed. So that means that anyone can run their own HTTP gateway, and users can pick the one that they trust the most. The API boundary nodes, on the other hand, those will handle canister API calls and route them to the correct subnet and replica node. They'll also provide caching and rate limiting, and they will provide, they will be managed and rewarded through the NNS like the replicas. We expect that the vast majority of API boundary nodes will be provided by third parties, with only a few of them by DFINITY, same as the replicas. So this will move us closer to our decentralization goals because more of the functionality of the boundary nodes will be moved under the NNS, and clients that support the native protocol can go directly to the API boundary nodes, and standard clients like web browsers can go through an HTTP gateway, but they don't have to use the DFINITY gateways. They'll have a choice in the gateway that they choose. That's it for me. I'll hand it over to Jan. Thanks.
Thank you, Raymond. Nice to see this all going on, and can't wait for this to be done at some point. Next, we have Or, and I guess he tells us about one of the reasons that at least stopped DFINITY.org and Internet-computer.org from being solely hosted on the Internet Computer. And both of the websites are actually on the Internet Computer, but as today they're still hosted on the cloud. And the reason was that SEO support was missing. So, Or, tell us more.
Yeah, on the boundary nodes team. So until today, optimizing search engine results for IC dApps has been a bit difficult. And this is because of our service worker, which limits the search engine from seeing the true content of a canister. So to work around this problem, some developers have resorted to circumventing the service worker, but this is at the cost of losing some security benefits that it provides. And to alleviate some of these pains, we have recently introduced a change that better supports search engines visiting dApps. And this enables canisters to utilize common SEO techniques and helps them become more visible in public search results. Next slide, please. So let's quickly see why this feature is even necessary. When you visit a dApp on the IC using your canister domain, behind the scenes, you are sent to one of the IC's boundary nodes. The boundary node, in turn, serves you a specialized piece of code called the service worker. This runs on your browser, and it ensures that neither the dApp you're visiting or the IC itself have been compromised and are serving you malicious content. Yes, so you can see this flow in the slide. Yeah. So, next slide, please. So for a normal user, once loaded, the service worker will then query the canister. It'll fetch its content and it'll show it to the user. So for example, a wallet, a chat app, or a social network. For a search engine, though, the story pretty much ends there, and all it will index is a preview page of loading a generic service worker. And obviously, this leads to poor search results. Next slide, please. So our recent change provides detection of web crawlers when they try to index dApps into their search results. And when these detections are made, the boundary nodes skip serving the service worker, and instead they serve the canister's content directly to the web crawler. And additionally, the boundary node performs the checks that the service worker would have made on behalf of the web crawler. This is referring to all the security checks that we gain from running the service worker. And this, in turn, allows the search engines and other SEO artifacts to behave as expected, allowing canisters on the IC to appear in search results under their non-raw domain name. Next slide, please. So since releasing this feature to production on September 21st of this month, we've seen it enable a great deal of benefits for dApp developers, such as social previews now working in platforms like Slack, Twitter, and Facebook, and canisters appearing in search results under their actual domain name. So notice this is not a raw domain. So for anyone rushing to try this, please do be aware that search results can take some time to update, as crawlers will revisit previously indexed sites. So it may take some time. And if anyone is new to SEO and looking for some insight, we do recommend you check out one of the SEO testing tools that are available online. We did leave a QR code for one that we were using for testing. Yeah, that's all from the Boundary Nodes team. Thank you very much for listening.
Thanks, Or. I can't wait to use my favorite search engine and try to search all the content on the internet computer. So next up, we have Ulan, who has news on Inter-canister query calls, implementation, and roadmap. Please take it away, Ulan.
Thank you, Jan. Hi all, I'm Ulan from the runtime team, and I will give an update about Inter-canister query calls. To save some time, I'm going to refer to this by abbreviation ICQC. So the idea behind this feature is to allow a canister to call other canisters while it's handling a query. And it is very useful for building scalable applications because it allows the application to shard data or distribute data across multiple canisters. And to see concretely why it's useful, let's look at this example where we have a user calling, sending a query to the blue canister. Without ICQC, the blue canister would need to respond to that query immediately, only using the data it has locally. And with ICQC, it can delegate parts of the query to other canisters, and then like by making queries and then collect the results and then respond to the user by aggregating those results. Now, it is one of the most requested features by community, but unfortunately, it's also one of the most difficult features to implement. And in this talk, I'm going to explain like the challenges and also share our plan to release the feature incrementally. Next slide, please. Right, before diving into ICQC details, I want to mention the alternatives that works today. Like the idea behind the alternative is to move the query calls to the client side, to the browser. So now the browser would need to do two steps. Like in the first step, it calls, like sends a query to the main canister and asks for the list of canisters that hold the data. And in the second step, it can send queries or call those canisters directly, maybe in parallel, then collect the results and aggregate the results locally. It has some disadvantages, like one being that the logic for sharding is duplicated in the browser. Another is that the latency increases because like the browser would need to do at least 2 queries. And more importantly, the network traffic between the browser and the node increases, right? And usually the network link between the browser and the nodes is much slower than the link between the nodes. But that said, the main advantage is that it is available now, it is well understood, it works with all the security features like replicated execution and certified variables. So if your application, if for your application the trade-offs are acceptable, I would recommend this as a good option to consider. Now coming back to ICQC, next slide please. Some of you may probably know that we have this prototype implementation available on some subnets. Those are verified application subnets. And the reason why the prototype implementation is not generally available is because it is incomplete and it is missing some key features. The main 2 features that are missing are support for cross-subnet calls and support for replicated execution. I will explain what that means a bit later, but these 2 are the main reason why ICQC is not shipped yet. Besides those, we have smaller missing functionality, like protecting against malicious canisters, misusing the prototype, to do a denial of service attack, for example, by doing recursive calls or generating huge call graphs. Specification needs to be written and performance can be improved, but these are smaller things that we know how to address. Now let's look into detail at the main technical challenges, and let's start with cross-subnet calls. Next slide, please. All right, so this diagram shows an example of a cross-subnet call. So here we have user sending a query to blue canister, and then blue canister is hosted on the subnet that has 7 nodes, and the blue canister makes this cross-subnet call to another canister on another subnet. Now, as you may know, some nodes in the subnet may be malicious, right? Not honest. And the protocol works if up to 1/3 of the nodes are malicious. What could happen is that if the first query goes to a malicious node, and then that node makes this cross-subnet call, in the call itself, it can put any data, right? And specifically, it can also put anything into the caller ID property of the call. And now the challenge is, how can we ensure that the canister that's being called can trust the caller ID, right? So we need to find a way to guarantee security of the caller ID. So this is one of the main challenges. And next slide, please. So I need to somehow find a solution for this caller ID problem, or maybe accept the reduced trustworthiness of caller ID. And there are some discussions going on that maybe it's not that bad, in the forum. And another challenge is that to support cross-subnet calls, we would need to kind of rewrite from scratch the algorithm using asynchronous and distributed algorithm. But that's kind of a technical implementation. What it means is that it probably will take a while until we have cross-subnet support. And if we want to get ICQC sooner, the proposal is to release it, but limit it to like same subnet calls, and then start working on cross subnet support. So if it is limited to same subnet, like then it's kind of related to co-location of canisters, and there is like work also going on in parallel about canister groups. Just mentioning that. Now moving on to the next challenge, replicated execution. First, I want to explain like why replicated execution is important. Like if, as you probably know, when we use a query, it goes to a single node and served by that single node. This is kind of, we refer to it as non-replicated execution because there's only a single node serving the query. And as I mentioned before, some nodes may be malicious, right? And if the query goes to a malicious node, the result can be arbitrary and cannot be trusted. This means that developers, when they're using queries, need to additionally ensure security somehow. And we today have two ways. One is to use replicated execution, and another is to use certified variables. And the next slide shows or demonstrates how like replicated execution works. It is also known as running query as update, but like I think replicated execution is more precise term, because if like query, even if like is running as update, we still discarding the state changes of the query. So when a user sends a replicated query, it goes not to a single node, but rather to the subnet, and all nodes in the subnet execute that query, and then they agree on the result, sign the result, and send the result to the user. And this means that the result is trustworthy, right? And we currently have this very nice property in the system that we can take any query and execute it in replicated mode. So it's kind of a way to achieve security. And next slide, please. In order to support replicated execution, it looks like we would need to rewrite like many parts of the replica, and we also need, like, the goal would be to get somehow support of multiple versions of the same canister in the replicated state. I will not go into like why into technical details, but I want to mention that we will be giving presentation at scalability and performance working group, where we will explain like all the technical details here. But the takeaway is that there is a lot of complexity and unknowns in implementing replicated support. And this means that it will definitely take a while, or it may even become maybe infeasible, right? And if you want to get ICQC soon, then this means then that we need to release it without support for replicated execution. But then we are kind of breaking this contract that exists currently for queries, right? That we can take any query and execute it in replicated mode. And to fix it, then we would need to introduce a new query type so that ICQCs are considered different queries than the existing queries that we have. So that's like our proposal. And in the last slide, I'd like to summarize what I said. And this would be kind of our plan to release ICQC incrementally. We are going to submit it as a motion proposal after like receiving the feedback. So the first step would be to get the existing prototypes that we have into the shape, like production ready shape, by like, as I mentioned, introducing new query type, implementing all the protection mechanisms, writing specification. Then after that, it would be available on all subnets. Then the next step would be start working on cross subnet calls. And the last step, which has a lot of uncertainty, is to try to tackle the replication execution. Replicated execution, right? Yep. And as I mentioned, we will have a presentation at Scalability and Performance Working Group on October 20th, where you can give like technical feedback. And there is also a forum thread where you can also comment. That's all from my side. Thank you, and back to you, Jan.
Thank you, Alan. I'm sure you made a lot of people very excited about this, and everybody, please give us feedback, participate in the working group, and share your thoughts on the forum. Next up, we have Manu, who's another regular of these sessions. namely update on threshold ECDSA.
Yeah, thanks, Jan. Hello, everybody. I'll give a very quick update on where we stand with threshold ECDSA. So as a small reminder, what we're doing here is trying to give canisters an ECDSA public key and add an interface that allows canisters to request signatures under that key. And that is useful because this allows a canister to hold, for example, crypto assets like Bitcoin and Ethereum and many others. But also because it's a very standard signature scheme, this kind of allows canisters to sign data and authenticate towards the rest of the world. And this will work with threshold cryptography, right? So to keep this secure, different replicas on the subnet all hold a piece of the secret key, and they can come together and run some protocol to create a signature if a canister requested. But this is done in a way that the key does not exist on one machine ever. It's always distributed. Next slide, please. Okay, so what are we working on? Well, hopefully, as you know, we've already released this beta key, so it's kind of already functional, right? You can use it on ICP mainnet today, but it's marked as like a testing key that will disappear at some point. While we're working on making it rock solid. One of the things we're concretely working on is performance. So we're working on the throughput of this. I think now we're around 1 signature per second on a 24-node subnet. And there's making these ECDSA signatures in a threshold way is actually very, very involved. So this is a number I'm already quite proud of. And the other part we're working on is security. So we're doing more internal security review, brushing up the specification and making sure the implementation and the specification match. Yeah, so this is other work that's ongoing. Next slide, please. Then the main thing I want to give an update on is, I guess there's this concern still that even though it's threshold ECDSA and the key is distributed in the subnets, there's still the concern that somebody might do like a smash and grab attack, with, like steal the state of the machines of many machines at the same time. So more than a third of the nodes of a subnet that holds an ECDSA key. And that would give the attacker the key. And so now if your canister used that key to hold Bitcoins or so, they could theoretically be lost. So this is a concern that I guess we've been thinking about, and I think it's also been brought up by the community. And we're working on many different, we're thinking about many different paths to kind of address this concern. One is enabling AMD SEV, which is the trusted execution environment from AMD. This would, of course, make it much less likely that this would make it much harder to extract a share of the secret key out of one machine. So it would make it much less likely that you can do this. Here, I guess there are some challenges with the hardware spec. So we're moving to the new hardware spec, and what's easier said than done to actually enable this, and new hardware has a long lead time. Another thing that we want to do is increase the subnet size for an ECDSA subnet, such that while it's still true that if you break into more than a third of the nodes at the same time, you can steal the key. But now if we make that number bigger, then I guess 1/3 of the nodes is still maybe a large amount that we say is sufficiently secure. Of course, also here, adding nodes, well, it's more computationally expensive, so that's a downside of this approach. And then other challenge is, again, the lead time of hardware. So for this, the more nodes you want to bring on, you always have to think about the delay. A third option we're exploring is using a higher threshold, which means you need to corrupt more than a third of the nodes to steal the key. This we can do, but it comes at a price, namely that then the liveness guarantees are less strong. So then we can tolerate maybe more than a third nodes having their key stolen. But if more than a third of the nodes are offline, then you would not be able to get signatures at that time. So that comes at a bit of a price. So maybe you can envision different subnets having the same key with different thresholds. And the fourth option is maybe rotate nodes between subnets. that's actually a lot easier to achieve. So maybe if you do that regularly, then it would make it harder to like break into many machines at the same time, because or like you would need to do it at the same time because nodes are constantly changing, and for that reason, it makes the concern less likely. Yeah, so this is a quick update of all the things we're looking at. We'll be sharing more. I think there's a blog post coming, and we'll share more on the forums once there's concrete actions, or maybe ask for feedback from the community. Yeah, but that's a quick update from my side. Back to you, Jan.
Thank you, Mani. Good to hear that, and I guess I mean many people are expecting this to go out very soon. I mean, at the end of the day, it is like a complex cryptographic protocol that we're implementing. We really want to make sure that we have all the security issues covered, and we have great security here. So then, as soon as we're convinced of that, we got to put it out. So with that, let's move on and see some live code. And the first one is Jason, who will show us what his team has been working on to make the lives of developers much easier again. Jason.
Thank you, Jan. Hello, everyone. Jason here, engineering manager at DFINITY. So I'm excited to demo a new feature we're bringing to the SDK. We're calling it the DFX shared replica. And to give you a little bit of background, here's a snapshot of some of the feedback we've received over the last several months, either on the forum or on Twitter or other places. And just to illustrate here, you can really feel the pain that's emanating from these snippets. So we know we have a lot of room for improvement when it comes to developer experience, and we want you to know that we're listening. Our goal is to provide all of you with world-class tooling for the internet computer. Next slide, please. So if you recall from our previous roadmap presentation, we laid out several key themes that we'd like to focus on for the upcoming year. The feature that I'm about to demo falls into the DFX quality of life theme, which is about improving the overall day-to-day experience of using the SDK tooling. So let's get into what that's about. Next slide, please. So DFX shared replica, what is it? So rather than spawning a replica instance per project, DFX will now spawn a single local replica, and it will manage a pool of canisters on a global network on your local machine. We did this because it was difficult and often error-prone for users to develop multiple projects simultaneously. There was no way for independent projects to communicate with one another. And we'd received dozens of error reports that were the result of incorrect or malformed configuration related to project-specific setups. So ultimately, we developed this feature to help ease the developer pain, improve the user experience. And so the behavior that I'm about to show you is now the default, but it is still possible to make use of the old behavior by defining a local network field in your project's dfx.json file. So next slide. And if I may share my screen, please. Okay. Okay, so here's my terminal window, and I'll show you that I am running the latest beta version of DFX. And just to show you here, I'm in my home directory. So notice that there's not a dfx.json file here. And what happens when I run dfx start then is I run that global instance. And you'll also notice that we cleaned up the console output here. If you want to bring back the debug information, you can launch dfx start with the verbose flag. But okay, in this terminal window, I have my local replica running. And what I'll do is I'll go over to another tab where I have the counter example from our examples repo, and another tab where I have the hello world example. So to kind of show you this, here's the counter app. And I can just run DFX deploy from here. I don't have to run DFX start. I don't have to, rimwrap the .dfx folder. I can just run DFX deploy, and this will deploy this code into my global instance running on localhost 4943. So we've also changed the default port. And then there it is. So let me go over then to the Hello World example. And again, I don't have to run DFX stop in the previous project. I don't have to run DFX start again here. I can just run DFX deploy. This will build the canister, and I can view it right away. And there's the Hello World example. So can we go back to the slides, please? Next slide. So this will ship with DFX 0.12.0, and it's available in 0.12.0 beta 3 today. There's the installation command if you'd like to give it a try. So we'd love to hear your feedback, and the squeaky wheel gets the grease. So if there's anything you think we can improve, please shout at us on the forum, start a discussion on GitHub. We want to hear what your feedback is. We want to hear your pain. We want to know how we can make these developer tools better for you. So that's it for me. Thank you very much. Over to you, Jan.
Thank you, Jason. Now that the DFX team has made coding so much easier, we want to give you some inspiration of what you could be coding up. And actually, the next one I'm very excited about, also for what it does. And really, Ben and Dominic have been busy the last 10 days to working on a proof of concept that addresses one of the probably biggest problems of all the dApps out there today. So Dominic, the screen is yours.
Thank you, Jan. So hey, I'm Dominic, solution architect at DFINITY. And yeah, today we want to show you how dApps in the greater Web3 ecosystem can benefit from the IC. You may know already that dApps often only have a decentralized core. That means only the core business logic is implemented in smart contracts, but in particular, the front ends are hosted on cloud platforms. And also key management is still really hard for users. Private keys and seed phrases are really not user-friendly and hard to keep safe. And the result of this is unavailability of dApps and services and loss of funds due to hacks. So next slide, please. So the IC provides unique capabilities to tackle these issues, and you're probably already aware of most of them. So the IC can host full stack dApps on chain that are directly accessible with a common web browser. It supports authentication to the dApps with biometrics and hardware keys. And you've heard it from Manu already. Via threshold ECDSA, it's possible that canisters can hold private keys or can sign messages. And this is the basis for canister-based wallets that can be used across the broader Web3 ecosystem. So next slide, please. So in order to show you how dApps can utilize the IC, Ben and I created a small demo based on Uniswap. For anyone who's not aware, Uniswap is the most important decentralized exchange, and it allows to swap you all kinds of tokens. And with that, can I share my screen to show you? One moment. So the first thing we've done is to just host the front end of Uniswap on the IC. So this has been possible, I guess, since the day one of the IC, maybe not particularly exciting. So, but let's see when we click on Connect Wallet, there's now a new option connect to the internet computer, so to a canister-based wallet. So let me do that. And it opens internet identity, and I can authenticate myself with my fingerprint on my Mac. And then it takes a bit because the canister doesn't cache the public key at the moment. So it takes 2 update calls to get the public key that is for this specific identity and canister. So it takes longer than it takes usually. Now let's do it again. So finally, we're connected, and we already put some ETH on this canister-based wallet. And now I can, look what Uniswap offers me. It offers me quite a lot of tokens. I bought some Uniswap yesterday. Let's go now with some Aave. Oh, so how much do I have? Let's get 1001. And this will give me some Aave, and I'll swap and confirm. And now the transaction is getting signed by the canister, and then sent to the Ethereum network. And so the transaction is submitted. We can look at Etherscan. Transactions pending, and in a few seconds we should have some Aave. So here we go, success. Let's go back to the interface. And now I have an Aave balance. So let's get back to the slide, please. Stop share. Okay, so if you want to try it out yourself, we have hosted a version that is connected to the Girly ETH testnet. You can try it out yourself, but use it at your own risk. There's currently no easy or simple way to get your funds back from the canister. Next slide, please. So here is what we did, and the main point is that it was really easy and everyone can do it. So we hosted the Uniswap frontend on an asset canister, and the Uniswap frontend uses a common pattern in Ethereum dApps that it has a standardized library and interface called a Web3 provider and signer, and we basically just hooked into this Web3 signer and implemented an interface to a canister-based wallet. And Ben implemented a signing canister that basically provides the functionality of the threshold ECDSA feature. So next slide, please. If you want to learn more about the signing canister, Ben has attached a nice UI to it that explains a lot what's going on in the inside and allows you to sign basically any Ethereum transaction. Next slide, please. So that's basically it from me. Now it's up to you. There is a lot that can be built with this, and we hope to support you in that. So you can deploy the front ends of all kinds of important apps on the IC, and you can build much more powerful omni-chain wallets. What I'm also really excited about is that the IC can help current DAOs to really be autonomous. So with that, back to you, Jan.
Thank you, Dominic. So exciting to see this, and mind you, this some people have noted in the chat, used the task key, and it's just a proof of concept, and merely to show excite you guys. And please take it away from here. There's so much stuff we can build that's so much powerful on the internet computer. And obviously, if you have something like that, you want to make it DAO governed. Yeah, with that, we're getting to the end of the global R&D. And I'm very excited and honored to have Dennis from Apocalypse with us today. And they're showing us like the next level of NFT, the next generation of NFT. Again, something that is only possible on the internet computer. So Dennis, the floor is yours.
Thanks, Jan. Can I share the screen, please? Okay. All right. Hi, everyone. My name's Dennis Dyack, and I'm the CEO of Apocalypse. We make video games. And Apocalypse is not the end of the world, as a lot of people think. It's actually ancient Greek to reveal the unknown. And the whole goal of Apocalypse is to give gamers experiences that they've never had before. So one of the premises that we're working on is to give gamers what they want. And we're of the belief right now that in Web3, a large portion of the games that are out there are doing it all wrong. And one of the fundamental principles we want to do and work on is create games that are based on Web3 that gives gamers exactly what they want. One of the first problems we started looking at was NFTs in general and the misconceptions with NFTs. And one of the first ones is, of course, that an NFT is simply a token. And often the casual user will generally buy an NFT and think they're actually buying some asset, but in reality, they're only getting that asset. So one of the first things we started doing is how can we start securing large data? You know, obviously the internet computer is perfect for this. And so we started forwarding the concept of an NFO. And what an NFO is a non-fungible object where you can start storing large, secure code, images, data, and more on blockchain. So gamers are actually getting what they think they're getting. So in some cases, you can buy, say, the Mona Lisa that's digital with an NFT. If that actual asset is insecure and someone decides to swap that asset out, then you're only left with the token, which is a receipt. So what we want to do is secure that. So this is a fundamental building block that we're working on with the engineers at DFINITY, and this is all running on the IC. So a couple heads up for this demo that we're about to show is, first of all, if anyone's 16 years or below, this is a mature game, so be aware there's going to be a bit of blood here. We're working on a game called Dead House Sonata, where you play the undead fighting the living, so we're going to be playing a vampire here. And the actual game is running in Unity, while all of the code is running, obviously, on the IC real time. And here we go with the demo.
All right, so let's get this started. You can see here through Dead House Sonata, we're going to log in through the internet identity. You can see we're about to sign in and click. So we log in, and we've blurred out some of the information. We're going to make sure this is us for the internet identity. You can see it processing here. And once we're logged in with the internet identity, it will return to the game. And you can see still working up in their upper right-hand side, and it says we don't have any items. And that is because we have not played the game yet or gotten any items, but you can see the internet identity integration is indeed in. Okay, here we are playing the game, running around as a vampire. And we're starting wave 1, in which we're going to start to kill enemies. And as soon as they drop something, we will check out to see what they drop. You can see some debug data here with some of the enemies as we're doing damage. Again, just fighting enemies until we get a drop. There's our first drop. All right. And you can see here it's a hemomancy drop. And after we get that drop, it will be transferred to the IC. And you can see the game is not slowing down at all, which means this is processing in the background. And, you know, we will continue to play, fight some more waves. Changing realms to get some mana, boosting our mana so we can fight. On to the fourth wave. Again, gonna fight some enemies, looking for more drops. And you're seeing here, once we pause the game, we're opening the profile, and it's showing the hemomancy drop that we just picked up. That is indeed on the IC. And so now we're opening a web browser to show that it's not only integrated completely seamlessly into the game, but you will be able to check your items on the web browser. So we go to here, we're just tabbing out. And there we go. There it is on a web browser. And you can see that not only is it integrated into the game, but you can actually see it on the IC just through a normal web browser as well. That as we log in again, that it's still there from last time. So when you play the game again, all your settings are saved. Again, integrated through the internet identity. And now what we're going to do is add to these, increase their levels, add to the data of things that are already in the IC, and get a few more pickups as well. So once again, we're going to start with waves. Wave 1. We got another pickup. And this particular pickup is Relentless Thirst, another spell. This one stops you from being interrupted when you're using Insanguinate. Insanguinate is where you take blood from afar from enemies. As a vampire, it's one of your main utility spells. And we got another level of Relentless Thirst. There you can see us using Sanguinate, getting some blood. So now we have a level 2 Relentless Thirst. Here he's just going to retrieve some mana from the magical realm. He's changed into mist form here. Getting some mana, you can see he's boosting his mana back. Then he's going to go back to the physical state, away from mist. And then he will dispatch this enemy as well. Okay, and what do we get here? Another level of Relentless Thirst. So now we have 3 levels of Relentless Thirst. And once again, we're going to open our profile. And now you can see that we have level 3 of Relentless Thirst. And the previous Hemomancy pickup from before. So not only have we been collecting things, but we're now updating them on the fly. And that is all in the complete test of this integration. And you can see here just on the web browser, it's all there.
Okay. So one of the ideas here, of course, is to create a fundamental building block where we can start creating AAA games in Web3 where the data is actually secure and be able to store things like big data. So we are formalizing, and I know this is underway with the DFINITY engineers, the NFO system for everyone to use. And our goal is to merge ethical free-to-play with complete ownership, community DAOs on blockchain, which is something we think gamers really want. We have all kinds of ideas with storing player histories and really changing sort of the face of gaming. And this particular step is one of the small steps towards getting a complete integration where gamers don't even need to know they're using NFTs to get this new experience that they've never had before. We're very excited about it, and we hope everyone likes what they see. So Jan, there you go. That is the demo.
Thank you, Dennis. This is so exciting. So now, before I get out my sword and run away gaming for the rest of the night, there's like one more thing I want to talk about. And we should really celebrate like HTTP outcalls are live, because it has been hinted towards throughout the whole global R&D meeting. And if you have followed the NNS, what was going on, you've seen that we've submitted proposals to upgrade different subnets and change the parameters of these subnets to enable HTTP outcalls. So there we go. On the internet computer, it's actually the first blockchain where smart contracts are grown-ups and don't need to be spoon-fed information from some external oracles that sometimes are not all that trustworthy or can be hacked. So there you go. Take it, play with it. And if you go to the next slide, here's actually proof that this works. So here's a canister that we have built that feeds the ISP price data of Coinbase, and that's actually the canister that we're going to use to replace the centralized infrastructure that we had built before launch to determine the ICP to get in the ICP price, so that we can determine the price of the exchange rate between ICP and cycles. So with that, yeah, let's celebrate and play some games the rest of the night, maybe. Yeah, thank you all everybody for joining, and please join again next time on October 26th, and bring all your friends, and let's have a happy time until then. Thank you, everybody. See you then.